Hello everyone, my name is Rafael Antunes de Carvalho. Today I will be presenting the results of a cutting-edge experimental archaeology project conducted under the guidance of Professor Dr. João Carlos Moreno de Souza. Our work focuses on the fracture formation in lithic projectile points from the RSLN-01 archaeological site, also known as Abrigo Dalpiaz. The primary objective was to produce a reference collection of traceological fractures using the bow and arrow as a propulsion method. This dataset will serve future comparisons with archaeological points from the site. Our secondary goal was to contribute to Brazilian experimental archaeology by creating the first local reference collection for impact fractures, a key step toward strengthening traceological studies in South America. We used a traditional Uvaya wood bow and 9 replicate lithic points, 4 of Polonio type and 5 of the Garivaldinense type, each hefted onto eucalyptus shafts with sisal and polyester resin. Feathers from Guinea fowls and duck were used for fletching. As targets, we employ a mix of EVA foam panels and a pork rib section, allowing us to simulate a wild pork hunting scenarios. Photograph and video documentation were ensured through DSLR and mobile cameras. 2 types of raw material were used to replicate the archaeological points: dacite, associated with the Polonio type, and silicified sandstone, related to the Garivaldinense type. These materials were flint-netted to replicate the morphology and technology observed in the original artifacts. Over the experiment setup, we ensure experimental control over variables like point morphology, aerial weight and length, target distance, and shot count per point. However, some uncontrolled variables included the wind, the variation in kinetic energy per shot, and the exact spot of impact on their target. Factors that naturally reflect the complexities of prehistoric hunting. We documented during the experiment the number of shots per point, what kind of target material was hit, penetration depth, and the resulting fractures. These data were systematically recorded in a table to support traceological analysis. A quick overview of the results. Out of all shots, only 1 tip were broke from hitting the bone. The others occurred when hitting the wood. In total, we documented 8 macrofractures. Notably, 1 point concentrated 4 of them. Despite the small sample size, the fractures were diverse and comparable to archaeological specimens, which supports the experimental reliability. About the reference collection, we analyzed fractures under magnification, revealing diagnostic features such as step terminations, conchoidal scars, and ventral and dorsal fracture patterns. These images now compose part of our reference collections, ready to be used for future comparisons in archaeological traceology. At the conclusion, the study highlights the value of experimental archaeology in Brazil, even with limited resources, and the importance of local materials and realistic conditions in understanding prehistoric behavior. Additionally, the methodological choices like mixing EVA and biological tissues allow us to create a more versatile dataset adaptable to the reality of South America archaeology. Thank you very much for your attention. I hope this presentation has inspired a new reflection on experimental and traceological archaeology in Brazil and beyond.